let me introduce my next set of speakers and my next panelists for our discussion today. So again, people who are live with us on Ubilo, there are two parallel sessions running on at this moment. The first one being on human brains or AI brains, the magnificence of AI and ML, something that I'm personally very interested in. So my speaker will have to be ready for a lot of questions. So my speaker here today is Mr. Rajat Gupta. He's the Chief Digital Officer at Xebia. So, Mr. Gupta, thank you very much for joining us. And we're all really excited to hear your thoughts. And you can go ahead and start with your presentation.
Thank you, Tanya. Hi, everyone. Esteemed attendees, HODs, and all the various webinar listeners. Let me start by, first of all, narrating a quick story. In a remote building in Chicago, there's actually a very small crew of people who have put in a signboard in front of their building, and that signboard says, "Keep things simple." But what they're doing is not simple at all. Mark Gionski, who is the founder of that entity, he punches in a few keys on his laptop, and suddenly there is a grainy footage of a forklift which appears on the screen. This footage is actually a live feed from their AI toolbox called IFM Vision AI. And what this is doing is in real time detecting whatever is happening for any potential security violations. Now, that security violation could be a cellular usage. That security violation could be the driver not looking where he's driving. The security violation could be not following the tracks of the warehouse in which the forklift is operating, and so on and so forth. And they are building this kind of an AI for every single industry to make sure that there is a preventive information which can be gathered, probably alerted to the supervisors in case there is any security breach. IFM is just one of the countless innovators in a buzzing space called artificial intelligence, which is just getting hotter by the day. So, without further ado, let me take you all to the presentation for today, which is artificial intelligence, human brain, AI brains, and we'll talk about the present and we'll talk about the future. When we discuss the story of IFM, one might tend to think that AI is something which is very, very radical, something which is very, very niche, but that's not the case at all. Actually, AI is very, very ubiquitous. It's present everywhere. We all do Google as if it's a second nature, right? We search every day. We open up our maps and we look for routes. We are going to Amazon to buy things. When we are searching, we are seeing recommendations. We are interacting with so many voice assistants today, be it Alexa, be it Siri. All of them are actually uses of AI. But then what is this AI? How do we figure out what is this AI? And all of us hear a lot of keywords, a lot of jargons when it comes to AI. And today we're trying to keep it simple. AI is basically a sense of application of intelligence, to applied human machines. Now, AI is a vast field. In that field, it contains machine learning, there's deep learning. Further, you can narrow it down to reinforcement learning. So there are very subfields within AI on how to make machines intelligent. But to kind of like leave you with the perspective, this is how AI is changing the game. Earlier, humans were learning to adopt a technology. So we were learning programming, we were learning concepts, we were learning how to interact with the machines. So it was all the effort of humans to actually, work with systems. But AI tries to change that paradigm. AI makes technology learn and adapt to humans. And that's the magnificence of AI. That's simply a new age innovation that is just happening us and surrounding us and engulfing us as we are proceeding. This does not mean, by the way, that AI is new or it's just suddenly picked up. In fact, AI has been with us for many, many decades. if I go back in history, I'd say that the first discussion around the application of AI probably came during World War II, when Alan Turing made the Turing machine, which was a very highly computational machine to actually decode or decrypt the messages sent by the Nazi U-boats. And from there on, there has been always a discussion happening on making intelligent machines, machines which can understand humans, machines which can take intelligent and smart decisions, right? But AI has also gone through a lot of winters. These have been areas, sometimes, more than 5 years, 10 years, where the interest, the progress, and naturally, therefore, the investments in AI have really, really tapered down. But I feel that we have now passed all those winters and we're now into a phase, something that I like to call the eternal spring of AI, where AI has proven itself as a technology. It has passed all the hype cycles and it is now impacting us in every area of work that we do. So, how did this happen? Why is it that suddenly, I say that AI has moved away from these winters into this eternal spring? So, I think there are largely three forces at work here. The first is, around 2000s, late 90s, a lot of, the businesses, they actually started becoming digital. They started digitizing their journeys, their processes, their subsystems, thereby generating a lot of data. So suddenly we had this huge data stores that were available. The second thing that also started parallelly, almost coincidentally, with all of these was the great advancement in compute. Now, that compute could be actually advancements in the chip technology through GPUs, and now we have even TPUs available, or whether it be new distributed programming frameworks like big data and Hadoop to process information at a very, very large scale at a fraction of a time, or the emergence of cloud, where one could just immediately scale up, use whatever compute that is required to process large volumes of data. And the third force, which just came together because these two forces were prevalent, were great advancements actually in the algorithms. One of the major things that I'd like to highlight is probably the whole area of deep learning, wherein we use deep neural networks to actually come up with near human level performances in areas where machines were very, very bad. When I was growing up, I'm sure all of you know the same, speech to text was a very, very pathetic system. But now look at it. We use speech to text in our phones every day and it works just so beautifully well. Our pronunciation might be wrong, but it autocorrects. And that's how good it has become. Tasks which are always supposed to be very, very difficult for machines, but very, very easy for humans, such as understanding video, understanding images, recognizing what is an image, what are the objects in that image. Suddenly, using these algorithmic advancements, the machine started reaching almost human level performances in these very, very complex areas. So quickly moving on to a cloud technology landscape of what are the various AI practices today. So it largely depends upon what skill set does one want to enter. If we want to really get down into the research part of AI and build new models and build new libraries and build new algorithms, then clouds are today providing all the infrastructure such as Lambda functions and other compute platforms to actually code. Then there are these, awesome backend libraries like TensorFlow, scikit-learn, Theano, Torch, which have already encapsulated all the AI and the machine learning algorithms. And one can actually use these backends to start building their own AI. You take it one level higher, and then the various top clouds, whether Amazon or Microsoft or Google, they've actually built machine learning platforms which use multiple such backends at their core, and they have actually abstracted the whole process of development of AI to the top layer, where you have AI services, where the entire AI is now available as a service which you can just use in your plug and play in your application through either SDKs or through APIs. So, for example, there's a Vision API which helps you to basically recognize images, detect objects, and do a whole lot of wonders with that. Then the APIs around speech and language, which help you in the tasks of translation, speech to text, text to speech, language generation, and so on and so forth. There are empathy APIs which detect emotion in the human voice and see what is the tone. Is the user worried? Is the user agitated? And you can accordingly model your application behavior. So there's a whole lot of such innovative services which are now just plug and play from all these cloud providers. Gartner and Deloitte have actually done a lot of survey, and it is now proven that AI and analytics tends to be the top two used terminologies for CIOs, CEOs, and board of directors across the globe, which means that there's a huge investment, there's a huge demand in these areas. And from a CXO point of view, this is where they are looking at AI playing a big role in their organizations, which is to improve their efficiency, look at existing products and services and making them better, help them in their decision making, or probably do better experiences with their customers. And this is something that is prevalent across the globe, across all the industries. Andrew Ng, one of the most prominent AI practitioners, has actually compared artificial intelligence to electricity. The way electricity actually transformed every industry, AI has the potential to equally disrupt, and in some ways even more, all of these industries. Let's look at a few examples. Let's look at the transport industry. Earlier, we had some amount of AI in cars where AI was detecting the motions of the driver, whether the driver is keeping the eyes on the road, whether he's getting dizzy, whether he's responsive, and kind of like alerting the driver. Now we are already into an area where companies like Tesla are anyways launching their self-autonomous vehicles. We're talking about completely autonomous fleets of vehicles, which could be actually changing the way the entire fleet industry is working. And not only Tesla, a lot of companies, including Google, including Apple, they're all working in this area of completely automated and autonomous transport. Imagine if we put ride sharing on top of it, on top of an autonomous vehicle. So everything right from your mobility to your commercial mobility could be actually autonomous, and that could be the next big disruption in transport. Look at healthcare. Unfortunately, COVID hit us last year. It's a proven fact, by the way, that the healthcare industries and the ecosystems and the infrastructures of the top industries and countries would have actually collapsed if it hadn't been for AI. How many of us know that most of the industries actually use voice bots, virtual assistants, or chatbots to actually redirect the patients for their basic symptoms, for their next steps, and basically take a decision on ensuring that the patients are handled adequately to quite a great level, thereby reducing the pressure on their healthcare systems, these doctors and nurses. One survey has it that nearly 20 to 30% of such bandwidth was created because of use of AI. And today, AI is actually completely changing the healthcare industry. Be it detection of a malady in cancer, or be it helping in molecular structure decomposition to identify what proteins can attach to what cells, and hence fast tracking the development of vaccines. So healthcare is one industry which has really caught the cusp of it. You look at banking, the way AI is helping in fraud detection, in recommendations, in credit risk management. It's pretty much everywhere. Look at robotics. In fact, I'm not sure how many of you know that AI has actually started making great advancements in the field of robotics. Hansen actually launched a robot called Sophia. Now, Sophia is a very advanced AI robot. It actually is capable of social and human empathy detection. It understands the conversation, it detects empathy, and it can model its language and behavior and conversation accordingly. Sophia has kind of like become a celebrity over the last couple of years. It's actually featured on quite a lot of late night shows as a celebrity guest. Recently, I've heard it has even accepted the citizenship from the Kingdom of Saudi Arabia. Look where AI is reaching. This does not mean, however, that AI is something that we've already cracked. is something where we've already reached the pinnacle? No, far from it. I think we are just reaching the tip of the iceberg. There are so many challenges still available facing us in the usage of AI. The first is explainability. Today, most of the innovation AI is because of deep learning. But the problem is, the more deeper the model, the less explainable it is, the more black box it is. How can I and you take a decision if we don't know how did we arrive at that decision? How can we trust that decision? We must have heard this experience from Steve Wozniak, who is actually one of the co-founders of Apple. So when Apple launched Apple Pay, Steve Wozniak tweeted that the credit limit which was granted by the AI of Apple was 20 times to him compared to his wife, even though they shared all the assets. Is that fair? How do you explain something like that? Right? So we don't know what went wrong over there, but one can assume and safely assume that the model suffered from certain biases. The model was not fair, and therefore, comes with a lot of liabilities and risks, right? So there's a lot of work that one needs to do, and the industry as a whole needs to do in order to make the AI explainable, so that we can take decisions and understand how are we arriving at something, uh, what is it, what are the factors which are important in this decision making, and that will actually help in making AI ethical, something which is fair, something which is explainable, transparent, something which is not affected by gender or geographical or socioeconomic diversity. And that's probably the problem today, right? Because we're training all these models on data which has been generated, but most of this data which is generated actually captures this socioeconomic and gender bias. And when we are training the models on that and we're not understanding how it is interpreting that, these biases are now being inherently present in these models. So the industry really has to work a lot in making AI both explainable as well as ethical. Another big but fantastical area that is happening is this whole gamut of transformation from narrow to wide AI, something which is called artificial general intelligence. Whatever AI we experience today in the industry, it's actually narrow AI. Whether that be Siri or Google Assistant, we might think that they might be doing actually a wide variety of tasks, but no, they're actually doing one task and they're trained effectively in that one task. The idea is we as humans are actually capable of doing a lot of tasks. We are able to have our episodic memory, we are able to have our conceptual memory, we are able to have and marry all these instances and take intelligent decisions across one point or another. How can machines be able to do that? So there is this whole research which is happening in making models which are not only good in one, but a multitude of tasks, differentiated tasks. And that's something which is the future of AI, which is called artificial general intelligence. In fact, if I'll just share a quick anecdote with you, Google actually launched a new AI called Google Alpha Zero. It's one of the first model which is built on reinforcement learning, which actually teaches itself while playing with itself on how to get better at a lot of games. So it's been able to defeat the grandmaster of Go, a game which is 20 times more complex than chess. It has been able to learn chess and many other games, and just getting better at it. So probably AGI is no longer a fantasy, but a reality which will happen sooner than later. Now, in order to achieve this future of AI, in order to achieve the pinnacle, in order to make sure that AI is becoming more intelligent, but yet explainable, yet fair, skilled set, skilled people is the single most detriment or the obstacle. And this is a survey by SnapLogic. There are similar surveys by Deloitte, there's similar surveys by Gartner, who all talk about skill gap being this biggest obstacle in both the adoption and the usage of AI across industries. And we are not alone, and the country world west is not alone. We in India are actually facing this problem. This is an India Today survey which says that 95% of the engineers in the country were actually not fit for software development jobs by the industry. This is a survey. It said that 78% of the fresh hires in IT actually needed retraining and reskilling before they actually became employable. Right now, these are very worrying statistics, and of course, these statistics are something that the academia and the industry need to take together and address at a holistic level. Because let's be clear, I firmly believe that the country which becomes the leader in AI will become the next superpower. So this is something very, very important, that our graduates of tomorrow are actually making sure that they are becoming more skilled in these technologies. I am just going to talk about two to three such suggestions, but let's work upon this and let's think about how we can make and bridge this gap. The first thing that I think we really need to do is to make sure that our industry and academia affiliation becomes better. Can industry, which probably has a better insight in the whole understanding of the curriculums, actually co-create curriculums, co-create digital courses which can be used in the academia to teach more relevant information? Can we look at super specializations? Can we look at micro credentials? So if we have computer science graduates, can we have computer science graduates specializing in various industry 4.0 initiatives like AR/VR, like AI, like microservice, like DevOps, like cloud? These are all skills for today, but can we have these specializations now as part of academia? Internships have always thought to be a way to give exposure to students for industries, but clearly that's not working. What is wrong? I think something that is inherently wrong is that they are very, very time bound today. So what happens is industry is also probably looking at these internships as more of a duty that they need to do as part of either the CSR initiatives or as part of their outreach initiatives. They don't really see much value that they can extract from it. And for students also, such kind of industrial exposures are not beneficial. Can we look at the way we change this entire paradigm of internship? Can we have more continuous internships lasting for not 6 months, but let's say 2 years, with dedicated internship to employment opportunities? Students will also be more comfortable. They'll also be more uh, probably safer, but and the industry would also like to invest more in making sure that they are given the right opportunities, the right projects, and the right simulated environments to work. Lastly, and this is something that I really feel we should look at the West. They're doing this. How about industry experience for faculty? Faculty are the arm which is creating the future for tomorrow. Can we have some mechanism, some framework, some model by which the faculty can actually have good industrial experience, so that they can supplement their great academic research with relevant industry experience? And when they tie it up together, probably the realism and the context that they might provide to students would be just awesome. And probably that's something that can really change the game. And I see multiple examples of it globally. So as I mentioned, one of the leading practitioners in this field, Andrew Ang, he's been involved in the development or conceptualization of Google Brain, or doing the leading the AI practice at Baidu, which is a Chinese AI and search organization, right? Can we look at also making our learning more realistic, personalize the learning? Can we look at extending and making the pace at which the student can assimilate the information more realistic? Can we embrace open source? Because the latest and the greatest of the technologies and the biggest of the companies are actually embracing open source. Can we make that understanding and embracing open source a part of the curriculum and provide a more real and contextualized learning to the academia? We need to take this as a shared responsibility. We at Xebia feel that academia is our most important supply chain partner. They are providing us with the skills and the future of our organization tomorrow. And we really look forward to working with both the regulators, the policy makers, as well as the academia to make that happen. Thank you.